Hello guys, this is the third video in second chapter is matter around us pure. This video deals with mixtures and different types of mixtures. So first we have the definition of mixtures. Mixtures are formed by mixing two or more substances in any ratio. So these substances can be mixed in any ratio. Uh, another form of matter that we read was pure substances. So pure substances were made up of single type of particles, whereas mixtures are formed by mixing two or more types of pure substances. Next we have difference between compounds and mixtures. On the left hand side we have mixtures, on the right hand side we take compounds. So mixtures are formed by mixing two or more elements, whereas compounds are formed by reaction of two or more elements. Second difference is that no new substance is formed in mixtures, whereas in compounds a new substance is formed. So this new substance will have entirely different or new properties from the elements from which it is formed, whereas in mixtures the mixtures have properties of the constituent particles from which it is formed. Third difference is that mixtures can be separated by physical processes such as filtration, chromatography, crystallization, but compounds cannot be separated by physical methods. So mixtures can be separated by physical method, but compounds require chemical or electrochemical method to be separated. The next another one major difference is that mixtures combine in any ratio, whereas compounds are formed when elements combine in fixed ratio. So these are four differences between mixtures and compounds. This is one important question that is asked in the exams. Before we head on to different types of mixtures, we should know the definition of Tyndall effect. It is defined as the scattering of light by very small particles. For example, there is a small window in a room and light is coming from it. There are times when you are able to see the path of this light, because there are very tiny dust particles present in the air which scatters this light, and this process is known as Tyndall effect. Similarly, when you take a mixture of water and sand, some of the particles of sand are suspended in water, and when you pass light through this mixture, you are able to see the path of the light, because this light is scattered by the particles of sand that are suspended in water, and this process is known as Tyndall effect. So the path of the light would be visible because of the scattering of light, and this would be known as Tyndall effect. Next topic is different types of mixtures. So there are two types of mixtures: homogeneous and heterogeneous mixtures. Homogeneous mixtures, these are the properties of homogeneous mixtures, and then we have the properties of heterogeneous mixtures. So the first property is it has uniform composition, and by uniform composition we mean the two substances that are mixing will be mixed uniformly. So the particles will be distributed uniformly. For example, we have, say, this is substance 1 and the substance 2 will be uniformly distributed between them, this and then again. So this is a uniform distribution of substances. Next is no definite boundary. Homogeneous substances do not have any definite boundaries or visible boundaries. For example, when you dissolve salt in water, you cannot make the difference between salt and water. So no definite boundaries of salt and water. They intermix with each other very evenly. Third property is the particles cannot be seen with our naked eyes. So the particles of salt or of water cannot be seen with our naked eyes. These are distributed very evenly and very finely. Third, next property is that particles do not settle down when it is left undisturbed for some time. So the particles of salt will not settle at the base when the salt solution is left for some time. So this is the property of homogeneous mixtures. And homogeneous mixtures do not show Tyndall effect because the particles of one substance do not suspend in the other, rather they are evenly distributed and mix into the intermolecular spaces present between the other substance. For example, when we dissolve some salt in water, the salt particles are dispersed in the intermolecular spaces between the particles of water, and they are so small that they cannot scatter a beam of light passing through them. Some of the examples of homogeneous mixtures include salt solution, sugar solution, alloy, air, and further classification of homogeneous mixtures we'll see in the next video. Another type of mixtures are heterogeneous mixtures. The first property of heterogeneous mixture is that they have a non-uniform composition. And by non-uniform composition, we mean that there might be some particles of substance 1 present, followed by maybe a lesser number of particles of substance 2, and then maybe many more of substance 1 again. So this ratio is not fixed. So this could be unevenly distributed. Now there could be say hundreds of particles of substance 2 again. Next is they may or may not have visible boundaries. So some of the heterogeneous mixtures have visible boundaries. For example, a mixture of sand and water. So if you mix some sand in water, the sand will form a different layer and the water will be clearly visible. Similarly, when you try to mix oil in water, the oil floats on the water, which forms a clear visible boundary, and then water is present beneath that layer of oil. So it might form visible boundaries. And another example for such as the colloidal solution or a milk, you cannot see you cannot see visible boundaries. So heterogeneous mixtures may or may not have visible boundaries. Next is particles can be seen through naked eyes, or if not naked eyes, through a microscope. So particles can easily be seen. So for example, of sand you can easily see the particles, then again of oil you can easily see some particles. Even in milk there are very tiny particles that are visible. The next property of heterogeneous mixture is that the particles may or may not settle down when it is left undisturbed for some time. So for example, when you leave a mixture of sand and water undisturbed for some time, the sand particles settles down at the bottom. Another, if you leave the mixture of oil and water for some time, the particles of water will be at the lower end, whereas the particles of oil will float on it. So they may settle down, and in some other cases such as the milk, they won't settle down. So the particles may or may not settle down. Next property is that they show Tyndall effect, because the particles of heterogeneous mixtures are comparatively larger than those of homogeneous mixtures. They show Tyndall effect, so they would scatter a beam of light passing through them. Some of the examples include mixture of soil and water, milk, fog. Other examples could be a mixture of solid and solids such as salt and sand, or sand and iron fillings. So these could be the examples of heterogeneous mixtures. So there are various types of heterogeneous mixtures such as colloids and suspensions that we'll cover in our later videos. Thank you for watching this video. I'll be back with some more videos.